So now we are going to discuss here the work done in a thermodynamic cycle. We have discussed previously that work done during a thermodynamic process, this is a thermodynamic process. This shows the expansion process. Is if you take this elementary strip, then work done is equal to area under this strip, which is PdV, and total work done is integral of this because this is a continuous process. If work is done during this process by the system, as it is happening here, system is expanding, the work done is positive. If it is done on the system, compression process, work done is negative. So you can say that the work done during a process in a thermodynamic cycle is equal to area under the curve showing that process. So we have here this thermodynamic cycle called Carnot cycle. So here work is done by the system, work is done on the system. So you can say that area, total area of the cycle is equal to W net work done by the system, which is equal to the sum of the negative and the positive work. The positive work which is done by the system and negative work which is done on the system. So we can find the area of a cycle, and this will be equal to the net work done by the system during this process. And suppose a cycle is of this form. It is having two loops. The direction of the loops is like this on a property diagram. These may be two circles, maybe triangles, maybe another type of loop. So the total work done is equal to work done by the system and work done on the system. If you take the direction of loop to be clockwise, then we take this as positive work, that is the work done by the system. Counterclockwise, negative work is done on the system. So for this loop, suppose area of this loop is A1 and this is having area A2. So this is having positive work in this direction, this is having negative work. So W net for this is equal to net work, that is positive plus minus A2. So this is the net work done during this cycle. So this is how you can find the work done during a cycle. Now let us take an example. It is given that a thermodynamic cycle is shown with a circle on PV diagram. Volume is in meter cube and this is in Newton per meter square. The maximum and minimum values of pressure and volume are given: 100 Newton per meter square and this is 50 and this is 100 meter cube to 150 meter cube. You have to find what is the value of work done during this cycle. As we know that work done is equal to the area of the cycle, which is equal to the area of the circle, and the direction of the process is like this, counterclockwise. So work is done by the system, so it will be positive work. Area of the circle, we know this is equal to pi r square. But you know that if I have the circle which is having the same dimensions of radius along the two axes, r which is having same dimensions, means radius this direction, then I can write this as pi r square. But if you convert this into an ellipse by applying some force, then you have this radius as a, this radius is b, so the area of this circle will be pi ab. So if you compare these two, w equal to pi r square, r will be equal to under root of a into b. So similarly we have different scales on the two sides, so we can write this as equal to pi r1 r2, r1 on this side, r2 on this side. So by calculating the area, we can find that W work done by the system, here it will be positive work. Pi into R1 is radius on this side, 150 divided by 2, and this is in meter cube. R2 on this side 100 minus 50 divided by 2 Newton per meter square. So pi into 50 by 2, 25 into 25 joule, Newton meter joule, 625 by joule. This is the work done by the system during the process. And if you want to know the heat exchange during the process, then for a cycle we have dq is equal to dw, thermodynamic cycle. That means that the total heat exchange during the cycle equal to the total work during the cycle, 625 joule. This is true for a complete cycle and not for any particular process. So this is how you can find the work done during a cycle, and that will be equal to the area of the cycle, and this is how you can find it out. In case the cycle is shown having different loops, then this way you can calculate the area and add the total area. Let us take another example of this. We have a thermodynamic cycle. Let me draw the diagram for this first. PV diagram. This is the cycle and the direction is shown . And the pressure and volume, here the pressure is P0, at the center point it is 2P0, and here it is 3P0, and the volumes at this point and this point they are same. Similarly here they are same, and these are V0 and 2V0. We have to find what is the net work done by the system. So here it comprises of two loops, 1 and 2. Now this loop, you can see the direction of the loops. This loop is in counterclockwise direction, loop 1. So loop 1 counterclockwise, that means negative work. Work is done on the system. Loop 2 clockwise, that means positive work. Work is done by the system. And you know that work is equal to area of this loop. So work W1 during this process, this is negative work done. Area of this triangle, half into base 2V0 minus V0 into height. This is 3P0, this is P0, 3P0 minus P0. So V0 by 2 into 2, so P0 V0 minus. Work is done on the system. W2, work done by the system. Area of this triangle, half 2V0 minus V0 into 2P0 minus P0. P0 V0 divided by 2. So this is the work done by the system. And if you want to write the value of the net work done during this cycle, that will be equal to the sum. So W net is equal to minus P0 V0 plus P0 V0 divided by 2 minus P0 V0 by 2. It means that the work has been done on the system. Net work is done on the system. So this is how you can find the work done during a thermodynamic cycle.